Hello everyone, I am Mohammad Adnan Rahman, an undergraduate student from Bangladesh University of Engineering and Technology, BUET. I am also an undergraduate researcher of TRIPS Lab in BUET. At the same time, I am the General Secretary of AC Student Chapter BUET. The title of my presentation is Decoupling Road Network Structure and Transport Emission Patterns, Entropy Insights from a High Resolution Inventory in a Data-SCARCE Megacity. Before starting my presentation, I want to say thank you to the BTR Organizing Committee. Through this initiative, undergraduate researchers from third world country like me have got the opportunity to present their research to the whole world. So here is the list of my authors. All of us are undergraduate students. Three of us are from BUET and one from Jahangirnagar University. So first, let me walk you through the underlying story behind my research. Once I have come to know that Dhaka city, the city where I live in, is one of the most unlivable cities in the whole world. The situation has not been changed yet. As we can see in the IQAir air quality ranking, Bangladesh has one of the worst air quality. That makes me thinking, what is the culprit behind this poor air quality in Dhaka? What I have found is really interesting. A significant portion of this emission is actually coming from road traffic, transport emission. So that takes me into another research question. What are the factors behind this high transport emission in Dhaka city? While analyzing the transport emission data of Dhaka, I found that there is actually no data. So that is the problem of data scarce megacities of global south, that we do not have any regularly updated vehicular emission inventory framework. But the fact is, Dhaka is not the only data scarce megacity of the whole world. In case of India, they have developed VAPI framework, which is the Vehicular Air Pollution Inventory Framework. It is mostly dependent on open source data. That is not data intensive and no field survey is required. So there is a good scope of using this framework in Bangladesh or Dhaka. But the problem is, this framework is dependent on Indian emission factors, which cannot be readily adaptable to Dhaka because Dhaka has its own traffic signature. Our traffic system is heterogeneous and no lane based, which is very different from other parts of the world. But this problem has been solved by one of my direct teachers, Shadab Isra Khan sir. They have developed representative driving cycle based emission factors, which is local emission factors for Dhaka city. Shadab Isra Khan sir is going to the Kara Kukulman's laboratory this fall, so I wish all the best for sir. Now, this is my study area. I have already discussed why this is the right test case for studying transport emission. That takes me to the first part of my methodology. I have combined the VAPI emission framework with the representative driving cycle based emission factors developed by Shadab Isra Khan sir and ultimately got the city scale transport emission inventory. But the problem has not been solved yet, we just got the data. Our target is to relate this transport emission inventory with the policy framework. To do so, we need the spatial distribution of transport emission. Luckily, this problem has also been solved in the literature. There are so many variables that we can use to spatially downscale a city scale transport emission. And here is the list of these variables from our literature review. And definitely, all these variables are not available for Dhaka open source. So, three open source variables are selected. These are population density, land use, and road density. And that is the second part of a methodology. Following this part, we have developed spatial distribution of transport emission inventory in a grid of 1 kilometer. But still, the problem has not been solved because a spatial distribution cannot be directly linked with policy implication. For an example, seeing this spatial distribution, we know that where the cluster is happened. We know the location of the cluster, but we do not know quantitatively how much clustered it is. That is the problem, and that we try to solve in our research. That is the exact place where entropy comes in. You can say that for hotspot analysis, we could also use GI star, but the problem is GI star answers where the hotspots sit. That I was discussing in the previous slide. It cannot answer how much concentrated the whole distribution is. Even if we use Moron Psi, it is a spatial autocorrelation tool and it answers that whether the values cluster or not. This is one global number, it is not a measure of dispersion. On the other hand side, if we use Shannon entropy, it will give us a scale between 0 to 1. If the value is near to 0, we can say that the pattern is hotspot dominated. And if it is near to 1, we can say that the pattern is diffuse. And we have got a quantitative idea how much hotspot dominated or how much diffuse it is. Now, as we got the entropy idea, the research get a turns in this slide. Almost all the emission patterns or emission studies are mostly from the demand side. They have modeled the transport emission from the demand side factors like activity, got the data from OD survey, etc., and so on. But our research is that we want to relate the emission pattern with the supply side of transport, the road network. This is not even a novel angle. There is a growing literature about relating the transport emission and road network structure. Two has been shown here, and the entropy concept is also inspired from this research. However, the objective of my research is to find the relation between road network and emission pattern, not the emission magnitude, which has been done in the previous literatures. So that takes me to the final part of my methodology, which is I have selected three variables: intersection density, aversion node degree, and straightness to represent the road network structure of Dhaka. These three variables actually suggested by Boeing, which was my previous slide I have shown. And finally, I have related these three variables with the normalized Shannon entropy that I have been discussed already using multivariate OLS regression. So here is the network analysis part. I have collected the polyline data of Dhaka's transportation network from OpenStreetMap, generated the nodes of this polyline, and filtered the nodes which are actually the intersections. Thus, I have got the edge and node representation of whole Dhaka's transportation network, and using that representation, I have calculated those three variables. Now, this is the list of my datasets. All of these datasets are open source. This is the descriptive statistics of my whole dataset. Finally, we have come to the results. As we can see, truck has the highest emission share among all these vehicles. So truck is the culprit that I was searching since my first slide. We can also see that the carbon monoxide and nitrogen oxide emission increases 28% and 31% respectively, and both these emissions actually violates the IPCC guideline. This is the spatial distribution of transport emission that we have developed, and this is the first ever spatially distributed transport emission inventory of Dhaka city. And these results are also generalizable to other cities of global south, especially the framework which does not require any field survey. It only requires open source datasets. So this is really a great contribution from my perspective. Now, as we have discussed earlier, the spatial pattern cannot directly be linked with policy implications. For that, we need entropy. We can see that the entropy of Dhaka basically near to 1 and it is persistent in all the years. So we can conclude that the spatial emission pattern, transport emission pattern of Dhaka city is actually diffused, not hotspot dominated. Why it is so important for policy? Because if we could find that the pattern is hotspot dominated, we should prefer policies which have localized effects or specially targeted policies like low emission zone or congestion pricing. However, if we find that the pattern is diffuse, we should rather go for city-wide policies like electrification, transit level of service increment, and so on. So we can conclude from this part is that for Dhaka, city-wide policies should actually be preferred. And this is the model result of OLS regression. As we can see that the adjusted R-square value is very near to 0. So there is actually no significant, statistically significant correlation between emission entropy and road network. So we can say that that is a structural decoupling of these two variables, emission entropy and road network. Finally, as our emission inventory is basically open source dataset based, we have done a remote sensing validation. This validation framework is actually developed by Goldberg, and we have seen that our R-square value is near to zero point 0.8, which is also consistent with the relevant literature, and we can say that our inventory is has enough accuracy. Finally, which policy implications we have developed from these studies? For Dhaka, our emissions are actually diffused, so localized policy measures cannot fix Dhaka's air quality. Rather, for Dhaka, we need city wide emission mitigation policies like electrification, increasing fuel efficiency, or increasing the level of service of transit. However, electrification must be paired with renewable energy generation, otherwise, the benefits will be eaten up by coal emission. And finally, this heterogeneity is not locked into road network. That is the headline result of my presentation. So rather than supply side of transport emission, demand side or behavioral patterns might be dominate this heterogeneity. So thank you so much. This is my presentation. Thank you so much for your attention. If you have any idea to collaboration with me, you are welcome.